Okay, welcome to grade 10 math. We're in unit 3 of quadratic relations. In chapter 7, dealing with factoring. And our lesson 2 is talking about common factoring. So by the end of this lesson, you'll be able to determine the greatest common factor and factor a polynomial using common factoring. So our last lesson, we looked at expanding by distributive property. We looked at it when we have a binomial and a binomial. So we can quickly do these two, and we can use the chart method if you like that method. And I'll show one without that method, but some people really like this way of doing it. So we're going to take one of those and bring it over here. And I'm going to take the other one and bring it here. And we split those terms up. So really you're just splitting the terms up. Now when they meet in the box, that's when we multiply them. So x times x is x squared. Over here, x and times 8 is 8x. And then negative 2 times x, they meet here, is negative 2x. And negative 2 and 8, they meet here, is negative 16. And then we always said, like, oh, these middle terms are common terms, so they can add. So you would have, this one doesn't have any common terms, so it's x squared. The next one is 8 minus 2 is 6x, and then negative 16. Okay, now let's say we were to do FOIL. Okay, so FOIL first, outside, inside, last. Well, we said with when we have a perfect square here, we're squaring the whole binomial, we do it twice. Okay, so first is the first times the first. Well, that would give us x squared. Okay, then the outside times the outside. That will give us negative 5x. Oh yeah, we were color coding those last time. Okay, then we do the inside times the inside. Negative 5 times x. Look how that repeats itself, because this is what happens in a squared one. Okay, and then finally, all right, negative 5 times negative 5 turns to positive 25. And then we see our like term here in the middle. And so we have x squared. Negative 5 minus 5 is negative 10x plus 25. All right, and you choose. You can do this next one by grid or by FOIL. So maybe pause the video and try it on your own. All right, we're back and we can try this. And so I'm just going to repeat this because this is the same thing twice. All right, well, 2 times 2 is 4, and x times x is x squared. 2 times 3 meets in this box is 6x. 2 times 3 in this should be the same because we're squaring it, 6x. And then 3 times 3 is 9. Then we gather like terms, and we have 4x squared plus 12x plus 9. All right, so good that we figured out how to expand. Now, the opposite to expanding, so this is expanding. The opposite to expanding is to factor. And that's what today's lesson is about. Okay, determine an expression. The area would be the length times the width. So area could be written as an expression, like the length is 2x minus 1. The width is another expression, x minus 7. Of course, now we have a binomial times a binomial, and we're going to do FOIL. So 2 times x is 2x squared. 2 times 7, negative 7, 2 times negative 7 is negative 14x. Negative 1 times x is negative 1x. Negative 1 times negative 7 is a positive now. Negative and negative is a positive 7. We have our like terms in the middle. Almost pretty much always, yeah. And so the first term is untouched. We have negative 14 and negative 15, negative 1. So negative 14 and negative 1 is negative 15, and plus 7. So if this is expanding, then the opposite is factoring. All right, so today we're talking about common factors. Common factoring. So we learned yesterday how to expand. Okay, so here they did the distributive property. 2 times 3 is 6. 2x times 3x is 6x squared. 2 times 5 is 10 with the x. Okay, so what is a factor? Factor is they are numbers that can multiply together to get another number. So 2 factors make another number. Expressions. There are expressions that can multiply together to get another expression. In the simplest form, here are factors. What are the factors of 24? We can write them all out. Well, there's 1 times 24 would give us 24. 2 times 12 would give us, again, 24. 3 times 8 is 24. 4 times 6 is 24. You see how they all end up equaling 24. Well, here's factors of 15x. Now this is an expression. 15x plus 10 are these two. And how do we get that? So that's how we're going to focus on today, is how do we get to those values. Well, we can kind of see that 5 goes into both of these. So we took 5 out. And if we divide, when I say took out, we mean factored it out or divided it out of these two numbers. So if we divided 15 by 5, we'd be left over with a 3. If we divided 10 by 5, we'd be left over with a 2. So let's go explain this more. So we already said that factoring is the opposite of expanding. Expanding we did yesterday. The greatest common factor is what we're looking for. Is the bigger number, or maybe the bigger variable that we could fit. Okay, bigger number or bigger variable, the largest. For example, how can we figure this out? Well, find the greatest common factor for each of these terms. All right, so in 35, what two numbers make up 35? So 35 and 75. So what can we split this up with? Well, we know that 7 goes into 35, and we know it goes in 5 times. Okay? So can we go any further? Does anything else divide 7? Okay, we can't break down 7 anymore by any multiplications or divisions. And same with a 5. It can't go any further. What about 5? Well, sorry, 75. Well, I know that 75 is like 3/4 in my pocket, so 3 times 25. Now, I can't go, can 3 be divided any further? No. Can 25 be divided any further? Yes, and the two factors that are 25 and 5. So 5 and 5 make 25. So there we have now found a common factor. And it's the greatest one because It's the furthest up on the division tree. These are division trees. So that's where our common factor is. So therefore our GCF, okay, our GCF is 5. All right, let's keep going. So we have 21x and we have 60. Well, 21 can be divided. Now the thing is the x common? Okay, so the x is not common. So it won't be found in both. Okay, so we can kind of scrap that. We don't need to factor in that. So what is the 21? 21 can be 7 again by 3. Can we break down 7 any further? No. Can we break down 3 any further? No. All right, so it's going to be one of those. So what is a 60? Well, 60 can be broken down to 6 and 10. That's an easy way. 6 can be further broken down into 2 and 3. And a 10 can go further into 2 and a 5. So you want to see if there's the greatest common factor, which is the highest number they have in common. They don't have 7 in common, that's a higher number. They don't have 10 in common, that's a higher number. But they do have 3 in common. And it might not be a large number, it might just be the only number that works. So that is the GCF is 3. All right, keep going here. Well, now we have 3 numbers to look at. 36, 9, and 18. So we could look and say, well, look, the x's are common, but they're not common in all of them. So the x's are not common. X squared, not common. So we don't need to factor them in. So we can scribble those out. So what is 36? Well, 36, an easy way could be 6 and 6. Can we break down 6 further? Yeah, 2 and 3. And that's both of them, right? 2 and 3. What does a 9 break down to? Well, 9 breaks down to 3 and 3. Pretty simple. 3 and 3. You might be wondering why we didn't do, like we at the 24 up here, we used the number 1. 1 times 24. It's true. We could have said, we could have gone like this, 1 times 7. But 1's not going to end up being the number anyways, because it's not a great number. It won't be the greatest common factor to have number 1. Okay, now what about 18? 18 also is broken down in 3 and in 6. 6 can go further, 2 and 3 as we saw before. So from that, what you can sometimes do is see if you have a greatest common factor that each of them go into. And so if we have a bunch of 3's, this is another way of looking at it. I have 2 3's here, 2 3's here, 2 3's here. Well, 3 times 3 is 9, and 3 times 3 is 9, and 3 times 3 is 9. So 9 is the greatest common factor. GCF is 9. You might have gone about this a different way. Like you might have said, oh, 4 times 9, 9 times 1. And you said 2 times 9. And we could have got those answers. So actually, we've made it a little harder on ourselves. But if you carry them forward, then you look for where there's common numbers, like 2 3's. There'd be no 6 here. So 2 3's, 2 3's, and 2 3's. And then 2 3's are 9. All right, some of this you can actually get really good at and do a lot of in your head. So we can keep going, find the greatest common for each set, common factors. So we can keep going and do the numbers like this. So 32, so 16 and 2. 2 goes no further. But what does 16 break down to? Well, 4 and 4. Okay. And then we can go even further. 2 and 2. 2 and 2. All right. I'll show you how that works then. Okay, now 40 goes 4 and 10. That's the easiest way. And then 2 and 2. And then if we go further, we have 2 and 5. Okay, so if you take the end of the tree, all right, if you take the end of the tree, including this end, how many in common do you have over here? Well, we have 3 2's. So do we have 3 2's here? Yes, we do. We have a 2, a 2, and a 2. And yes, we have 2 more, but we have 3 and 3 here and 3 here. So the greatest common factor, and notice how we've evolved a bit. We had some really obvious ones here, pretty obvious one here. Okay, here it got a little bit harder where we had to go back to the bottom of the trees, or it was really easy. We might have spotted the 9 right away. But here's the 3 times 3. And here we're kind of evolving. We were going all the way down to the bases of the greatest common factors. So from the 2 times 2 times 2, we get 8. So 2 times 2 is 4. 4 times 2 is 8. All right, here we have a bit of a different scenario happening. We look and we see, okay, what can I break 13 down to? 1 and 13. What can I break 20 into? 4 and 5, 2 by 2, and we see no common numbers. So no common numbers. But what about variables? So you can only have common to the highest degree, no, to the lowest degree. So when we say degree, the degree of the variable is x to the 2, so degree of 2. This one, there's an x to the 1, so the degree is 1. You can only have common to the lowest degree. So they both have, if we were to look at this one, this is x times x, and this one's just x. So to the lowest degree, there's only one x, and there's 2 x's on here. So there's 1x here and 1x here, just like we did with the 2's. In the end, we saw 3 common 2's and 3 common 2's with a couple extras. Well, here we have a common and a common with an extra. So our greatest common factor then equals an x. That's all. So no numbers, just x. Or 1x if you really want to just say that. So here we're probably going to, do we have a combination? So now that we've introduced the idea of a common variable, I almost like to check that first. Okay, do we have a common variable? No, no common variable. So there's no x here. There are x and x squared, but they have to be common in each. Now, if you just brainstorm, let's just do this in our head. Brainstorm. Can you think of a number that goes into 15, 9, and 21? So, all right, I'm going to pause the video. I want to you to think about that, and then I'm going to pull up something that might help. Okay, so something that might help is to look at a times table. So if we can take our numbers like we had of 15, 9, and 21. Okay, can we find where 15, 9, and 21 might fit in? Okay, so 15, 15, 9, 21. Oh, look at that. I found them all in the same row here. Right? 15, 9, 21. So what number goes with 15, 9, and 21? You know, we notice the 3 and the 5 and the 7. That's not consistent. So we look at the one row and we see the greatest common factor is 3. So usually we hand these factoring times tables out to people during the course. All right, so our greatest common factor is 3. Maybe we can keep using this as we go through. Okay, so that's the simplest version of finding the common factor. So always starting with the greatest common factor. Okay, so we're going to try a few of these out, and I'll show you how we're going to do this. So the first step we want to take is space here. So steps. 1, find the GCF of both terms. Second, put GCF in front of bracket of an open bracket. Okay. 3, divide first term by GCF and then put answer in the bracket. Put answer first in bracket. Fourth, divide the next term by GCF. Put answer second in the bracket. All right. 5, we would continue if necessary. Continue if needed. So what am I trying to say here? Well, we're trying to find a GCF. So can we think of what the GCF would be for this first example? So we have the GCF is, well, what goes in the highest number that goes into 4 and into 20. And sometimes you need to work that out. So 4 goes 2 to 2, 2 and 2, 20 goes 4 and, sorry, I should have did these branches 4 and 5. So we could have stopped here. So 4, or you can go further, 2 and 2. And then you're going to say, oh, well, we got 2s and 2s. So we have, well, 4. It might have been more obvious. So the GCF is 4. 4 goes into 4 one time. 4 goes into 20 5 times. So this is what's going to happen. We are going to put the 4 outside. And then I'm going to have a bracket 4x plus 20. But what we're doing is, because we put the 4 out here, we're dividing it. That's really how that 4 got there. The 4 just doesn't appear here. We're dividing both terms by that. So 4 still exists, and what we do is we say, well, 4 divides by 4 one time and one time. 4 divides into 4 once and into 20 by 5. And then we clean this up, and what are we left with? So we're left with bracket. There's only a 1 here now. 1x is just x plus 5. Okay, and this is factored now. Okay. It is possible to check. Sometimes it's good to check if your work is accurate. So if you were to check and you did this expand, okay, and you did 4 times x plus 5, okay, well, 4 times x is 4x, 4 times 5 is 20. And it's the same as our first answer. So correct. All right, good. So now it just said factor, but it didn't say check, but it's a good practice to check. So again, on this next example, we want to check if there's any variables. And look, they have x in common. So GCF, we can say will have an x. We just don't know what the number will be yet. Well, just doing our math in our head, you know, what's common from 5 and 30? So can we find any 30s? A 30 and a 30. Okay. Anywhere else that there's a 30? Well, and where are our 5s? Well, our 5s are here and here. Anywhere else we can find 5? No. So our greatest common factor is in row 5 or in column 5. So either way, it's 5. Okay. And you might have did this in your head. So, so for now it's 5x. All right, so let's take 5x out. Okay, and start with our original again. 5x plus 30. And the only difference is, sorry, I should kind of show it like what we're doing here. We're dividing 5x from both terms. So we have 5x. How many times does 5x go into 5x? Well, that seems simple enough. That should be 1 time. So we're left with a 1. Okay. And now how many times does, oh, sorry, I missed something here. We should have the x squared on there. Very important. Okay, so if you remember our laws of exponents, if we cancel 1x into the x squared, we're down to just an x. The 5 goes into 5 once, and the 5 goes into 36 times. So what's left over after we clean this up? 6x. All right, so 5x times 1 plus 6x. All right, that's good. That's factored now. Good. Does it get harder than this? Well, maybe. All right. These numbers are getting a little larger, so you might not have success with the times table all the time. So we want to use our division tree. And so we know that 48 is, well, it could be 6 and 8. It could also be 2 and 24. What does 63 equal to? So 63 is equal to 9 and 7. Okay, can we break down our, so nothing common yet that we see. And we would want to break that down to 2 and 3. We would want to break this down to 2 and 4. You can go further to 4, 2, and 2. Okay, now I don't think we're going to get any 2's in this 9. So 3 and 3 and 7. So what's the only common thing? So when you look at the bases of 7, 3, 3, 2, 2, 2, 3, and 2, the only thing we see common is 1, 3. So our GCF is 3, and it has an X in both. And here's the thing we haven't talked about yet. It has a negative in both. So the negative is common. It counts as the common. So we want to bring this number out and say negative 3x bracket negative 48x squared minus 63x, close your bracket. We want to divide both those by the common factor. Now, it's always going to eliminate because you know it's a common factor. So we just have to reduce it. So the x squared reduces to 1, and that x gets canceled out. The 3 goes into 3 once and goes into 18. 48, sorry, goes into 48 16 times. Okay, on this side. So far, we're left with negative 3x, and if we clean this up, also the negatives cancel each other out, if you notice. So negative divided by a negative is a positive. So we are left with 16 and an x. After all that's cleaned up, 16x. Okay, let's figure this one out. So the negatives break down, the x's match this time, and 3 goes into 63. Punch it in, and you get 21. Oh, I meant to do that in blue. But anyways, there's your answer. We can't go any further. Okay. Good. If we were to check this, right, negative 3 times 16 would give us back to 48. Negative 3 times 21 would get us back to 63. Okay, do we see any common factors? Now we're introducing a third term. So not to worry, basically you can start getting good at this and you start getting easier to spot it. So a GCF, do we have an X term in each? No. Okay, so we're not going to have an X term. Now we know 5 goes into 5. 5 works for 5 and 10. Would 5 work out for 120? Well, let's see. 120 divided by 5 would be how much? 120 divided by 5 goes in evenly, 24 times. So the 5 works. So we have a 5. We have 2 times 5. We know that works. We have a 5. So anyways, 5 is the common factor. So do the same way we've been doing it. Equals. So take out the 5. 5x squared plus 10x minus 120. Close your bracket. And we're taking out the 5 on each, or factoring out the 5. Okay, so then you reduce. Nothing changes on the outside. Okay, so 5 goes into 5, but there was no x to cancel, so we're going to left with 1x squared. 5 goes into 10 2 times, so we're left with plus 2x. And then 5 goes into 120 24 times because we did the math up here. And there we go. 5 times x squared plus 2x minus 24. Very good. You could quickly, then what you do at the end is you just quickly in your head say 5 times x squared is 5x squared. 5 times 2x is 10x. 5 times negative 20 is, okay, so it's negative, and you punch it in and, oh yeah, it's 20. Okay, so I know I did that right. And you want to double check your answers sometime. Okay, we're ready to move on to one that looks more complicated, but it's just the same idea. So if you put it into a word problem, they give you the expression and you just have to find out the dimensions. Well, finding out the dimensions are the factors. So the area of the chalkboard is represented by this, and we want to know what the dimensions are. So if we do 6 and 21, I have 3 and 2, I have 3 and 7. Clearly, 3 is common. Okay, so we can have 21x squared plus 6x, and I'm going to say, now we also need to see if there's a common x term, and there is. X's are common. So x squared and x, well, that's like saying this is x and x, so I have x is common. So overall I have a GCF of the 3 and the x. Okay, so that's what we're going to divide by. So take your 3x, build a bracket, and put in the other numbers. 21x squared plus 6x. And we're going to divide both sides by 3x and 3x. So what happens when we do that? Well, this x reduces, cancels, and this x becomes x to the 1. 3 cancels, and 3 goes into 21 7 times. So we have 7, and there's still an x remaining. The x's cancel out altogether, and the 3 cancels out to 1 when it divides when it divides 6 by 3. We get 2. So clean that up. We have no more x's. We just have 2. There you go. You could check this. Three x times 7x plus 2. So 3 times 7 is 21, and x times x is x squared. So now we're going to see a quadratic. 3 times 2, 6x, and that matches back to there. So therefore, the length of the chalkboard is 7x plus 2 units, whatever the units might be. And the width is 3x units. Good. All right, so that's factoring, common factoring. And yeah, thanks for joining and watching that. There's plenty of practice with BLM 7.2.1. See you next time.